did it when I was up there. I went over to his house. It's like, yeah, look at the end result.
Moving on to chapter 4. Remember, okay, guys. We got at the beginning of our second unit today. 4 through 6 are going to go together. The chapter title is not the red part, just the black part. Scatter plots and correlation. I'll explain the red text, but I'm going to give you a chance to get oriented there. Scatter plots and correlation, chapter 4. I have down bivariate data. Here's the big shift. In chapters 1, 2, and 3, we were basically studying one variable at a time. And we made histograms, we made stem plots, we learned how to do all kinds of measures of center, standard deviation. For the first time, we are going to consider two variables at the same time. That is why you see the word bivariate. Bi, just like, bicycle means two, and variate means two variables. And so, we're going to see graphs something like the one on the bottom of this title page, where we have two axes. We have like the first quadrant of a graph that you did back in algebra. We don't have to worry about the other quadrants because we're measuring real data, and negatives don't usually make a lot of sense, especially when you're counting things. You can't get negatives. So if you're wondering why are we just over in the top right corner on the first quadrant, that's why. That's actually called a scatter plot, and we're going to be learning, it's one of the objectives today, learn how to make a scatter plot. Here are the first three objectives. We're going to learn the difference between, I hope, an explanatory and response variables, make scatter plots, interpret scatter plots, and understand them. So lots to do with scatter plots. And I'm just going to point out a couple things from the book that I think were worth highlighting. I've already got them highlighted. On that very first page, page 79, it says one of the main themes is that the relationship between two variables can be strongly influenced by other variables that are lurking in the background. Just as a reminder here, so you know what I'm talking about, you should remember this little story. I'll just quickly bring it back. It was the idea that the Kalamazoo, Michigan was trying to get kids into this program called Mozart for Minors. And they put this ad in. They said, question, which students scored 51 points higher in verbal skills and 39 points higher in math? Answer, students who had experience in music. Pretty convincing statement, trying to get parents to get their kids in the program so that their kids would do better. But it gives a little bit of a false impression that study music equals higher scores. And we don't know that. All we know is when they're in music, their scores are higher. That doesn't mean one causes the other. So you got to be real careful about that. In fact, I know we talked about this. What are some lurking variables that we haven't even talked about behind the scenes that probably are the reason these kids are doing well? Probably caring parents. My guess, usually if they're in a program, the parents care and they probably have enough resources to get the kids to these activities and so forth. So I'm not just saying the other people don't care, but maybe they don't have sufficient money or transportation's not available, whatever. So beware. Just because two things seem to be related doesn't mean one causes the other. Major lesson. Okay, back up to where we were. The other point I wanted to make on this page, bad news, but it's true. Statistical relationships are overall tendencies, not ironclad rules. I wish it was different. Other math classes, you end up, this is the solution. In statistics, we have to end up by saying things like, yeah, there's a 95% chance that caused that. And you can't be 100% certain. So it's a little bit unnerving. It's hard for me, having taught math my whole life, to be honest with you. But it's the way statistics is. That's the same reason the weatherman can't say, you will have snow tonight. He'd probably be shot at sunrise. He already is in grave danger from a number of angered citizens, but that would really do it if he made a prediction and wasn't right. Made it that certain. Okay. Here's a couple scatter plots. You notice we have two axes, and this is a pretty interesting one. It's about sleep, distribution of sleep. Along the axis down on the bottom is the start of the sleep period, the time. And the axis along the left side, the vertical, tells you how many hours of sleep the person got. Okay, you'll notice during the central part of that graph, and by the way, this glow is supposed to indicate daylight, between, is that 6 in the morning and 6 p.m. Of course, it depends on the time of year. But anyway, when people started sleeping in this area, you notice how they didn't sleep very long. And when people slept when it was darker when they went to bed, even over here, early morning hours, or here, later in the evening, that the dots are higher, meaning they got more hours of sleep. Graph that tells kind of an interesting story. Always makes me feel for the people who work third shift or second shift. They have to have their bodies like kind of reversed. And, I don't know, there's something to sensing light and being in sync. I got to just tell you that for, 11 years? I taught at Lutheran High School on the other side of Lake Michigan, southwestern Michigan, St. Joseph. And because of the prevailing westerlies on the other side of the lake, this is typical winter. Even though the lake water is cold, it's relatively warm compared to the air in the winter. Okay? So what happens is you have this warmer water, cold air comes over the top of it. You can already sense what's going on. When you have cold over warm, they clash, and for one thing, they cause clouds. Every time when I come to work, I come from Waukesha, every time I come over the big rise on 94, right by Sunny Slope Road in Brookfield, I see this huge column of, especially on a cold, really cold winter day, you see this just solid clouds over the lake. I always think about the poor people over on the other side, because what happens then is not only clouds, I'm telling you, we didn't see sunshine for months there on some occasions, and it just gets to you after a while, it really does. And then on top of that, guess what else? The wind is blowing also from west to east, and so guess what? The clouds get blown over and you get lots of precipitation. It was warmer than it is here, but boy, it was gloom city. And after a while, I don't know, what do they call it? Seasonal affect disorder or something like that? Honestly, I really, even though I have not loved this winter, I got to tell you, I've really been thankful for the sunshine. Sounds like, by the way, we might get 5 straight days of sunshine this week. Cool. But anyway, these poor people that have to go to sleep when it's bright outside, it's just hard. I think it's hard for the body to do that inversion. But anyway, graph kind of tells an interesting story. I'm just showing you a couple others where you have, this is a scatter plot too. It's just points that may or may not have a pattern. Here, this is a wild one. You actually have a some kind of a circular pattern. Here's another scatter plot. It's a very common tool for measuring things in science. Sometimes you can even do a three-dimensional scatter plot. And it tells you some interesting relationships. Okay. 3 terms that we are going to need to make use of in this chapter. Explanatory variable, response, and then there's always those lurking variables. When you're doing a scatter plot, okay, I've already told you we're doing 2 variables. So the idea here is maybe is one causing the other. Example, we could plot along the x-axis maybe a scale of temperatures. And along the y-axis, we could maybe measure, I don't know, the lengths of icicles. And the idea, I'd want the icicle length to be here because the hope is possibly we'll probably see some kind of relationship between temperature and how long the icicles are. And the icicles sure aren't causing the temperature. Obviously, it's the other way around. So in that case, you can tell. The one that's causing it, that's called the explanatory variable. And that's the one you always want to have on the horizontal axis. The one that's resulting is called the response variable. In this case, the icicle length. Now, that's probably a bad example because if it's too cold, you have no icicles, right? You kind of need a combination of it's got to warm up and it's got to get cold. I don't know. So, but you get the idea. Temperature obviously causes icicles to get created, among other things. So despite that, here we use this term, and then what do I tell you? Be careful not to have one. Don't jump to the conclusion that one is causing the other. So even though we're using those terms, be real cautious about that. Okay, I guess it's time to dive in. We're going to do our first scatter plot. And for this example, we're going to look at, this is a problem in your text. And it's right near the beginning of the chapter. I'll get the page here. Yep, 8344 bird colonies. And just to give you an idea what's happening, one of the nature's patterns connects the percent of adult birds in a colony that return from the previous year and the number of new adults that join the colony. Here are the data for 13 colonies of sparrowhawks. Okay, so we have some scientific data, and each what do they call it? Each colony has a certain percent of birds that return, and then there's a new amount. There's some new birds that join. And so, like in this first colony here, 74% came back. 5% of them were new. Okay, what I'm going to do is set up some axes. We're just going to make one here. So set up a horizontal and a vertical axis. Because we don't really know, what do you think? What might be causing what? Do you think, for example, if you notice, if you just look real quickly, do you see how when you have a lower percentage returning, you notice how there tends to be more new ones? And just the opposite, when you have a higher percentage returning, it seems like we have a low. So it's almost like what? Maybe the percent returning might be the explanatory. We don't know for sure. So I'm going to label down here percent returning. And then along the vertical scale, this would be the percent of new. And then we got to make up some scale. Here, it's just pretty much a matter of what's the high number in the list. Let's see, for percent returning, what do we go up to? 81. 81 is the high. I'll just go, each line is worth 10. Okay, take me up to 80. For the new, the highest number I see is 20. So I think this is going to fit. We'll just have each two lines represent 5. It really doesn't matter, and I certainly don't have to keep the two scales, of equal. Okay, let's start plotting points. 74, comma 5. So we come over to 74 about here, and we go up to 5. 66, 6. 81, 8. 52, 11. 73, 12. 62, 15. 52, 16. 45, 17. 62, 18. 'Overlap our chart a little bit. 46, 18. 60, 19. 46, 20. 38, 20. Okay, that's it. That's our scatter plot. Now, a couple no-nos. You don't want to connect the dots. You actually want to leave them be unconnected. And we want to, then on the positive side, you want to see if there are any general patterns. And while it's certainly not perfectly orderly, it does seem that we have kind of what? Kind of a bar effect that's doing something like this. If we had to make an overall pattern, it's kind of doing this. And that makes sense. That is, as we get a higher percentage of birds returning, we are getting a lower percentage of new birds. As we get a lower percentage of birds returning, we're getting higher new. Kind of just interesting little, maybe God's way of keeping these colonies at least approximately equal, so that when less birds return, more new ones join. And they just kind of level off at a fairly constant number. Okay, that's a scatter plot. And we're going to talk a little bit about how scatter plots work. Okay. Now, this is probably a bad illustration, so make sure you listen. If the data was perfectly lined up, and our picture was doing this, it was going downhill. If the data had been we laid down a straight edge, they would have lined up perfectly, then we would have had a perfect correlation of -1. Negative because it's going downhill. Those of you who remember a little bit about algebra, remember that negative slopes, as they go from left to right, go downhill. It's kind of a nice reminder. It's not quite a slope, but it's similar. So what the number is, perfect, means, boy, they're lined up perfectly. If they're absolutely miserable correlation, then it's 0. So correlations are always between 0 and 1. 0, not there. 1, perfect. More typical, somewhere between 0 and 1. You can have them, there is one other thing we got to talk about. You can have negative correlation downhill, and you can have positive correlation uphill. To give you a feel for this, I made up, it's kind of corny, but I just made up some different scatter plots here. And this one, I think you would agree with me, there's almost no pattern here at all. They certainly don't line up. So this correlation, by the way, R is going to be the abbreviation you'll see a lot for this through this chapter. This correlation is really close to zip, nothing, approximately equal to 0. This correlation is pretty lined up, I think you'll agree, and it's heading downhill, so it's negative. And you know, anywhere on a scale from 0 to 1, I'm giving this a 0.8. Pretty lined up. Here, these are lined up even better. The points are really close to a line, and they're going uphill. So I'm saying, this is about a 0.9, and it's positive. This one over here, they're kind of lined up, but it's a little bit sloppy. So I'm giving this one about a 0.6 or a 0.7. Now, we actually will have an official way to give us, we're going to let the computers score most of this for us. But there's a formula for calculating how good the correlation is. And that's another thing we're going to be heading for, not today, but at a later date. So I just wanted to give you a feel. So no pattern at all, correlation of 0. Getting close to some kind of a line, higher numbers closer to 1. Uphill, positive. Downhill, negative. Yeah, this is just a reminder that we call the response variable the result, and this is the explanatory. And this is pretty corny, but a reminder in your notes that you want to always put your explanatory variable on the horizontal axis if you know, and put your response going vertically. And there's a good example here I want to go through. Sometimes we have what? A response and a explanatory. Sometimes we don't. Look at example 4.1, the effects of alcohol. It says that alcohol has many effects on the body. One effect is a drop in body temperature. To study this effect, researchers give several different amounts of alcohol to mice. Then they measure the change in the mouse's body temperature in the 15 minutes after they took the alcohol. The amount of alcohol in this case is the explanatory variable, and their change in temperature, that's the response, obviously. You know, I mean, it would be silly to think of it being reversed, wouldn't it? You know, would the change in their body temperature affect how much alcohol mice drink? Obviously not. So sometimes it's silly in reverse. Now, how about this? A person in example 4.2 wants to do, check out some voting patterns. A political scientist looks at the Democrats' share of the popular vote for president in each state in the 2 most recent presidential elections. She does not wish to explain one year's data by the others, but rather simply to find a pattern that may shed light on political conditions. The political scientist has 2 related variables, but she does not use the explanatory response distinction because she's not looking at one causing the other. You know, so then it's just 2 variables, and who cares which one is on which axis, because we don't know. Okay, so both kinds of scatter plots are possible. Sometimes you'll make a guess and say, well, I think this is the one that's maybe causing this one. But other times, we just don't know, and it doesn't matter. There's a little bit of practice here. Apply your knowledge. Here, we're going to throw you into the scenario and see what you think. Which is the response? Which is the explanatory? Or doesn't that even fit? A, the amount of time a student spends studying for a stats exam and the grade on the exam. What do you think? Do we have a explanatory response there? At least to some extent, there's probably, what, the amount of time spent probably is explanatory. It's not completely it. And then the score they get on the exam would probably be the response. How about B? The weight in kilograms and the height in centimeters of a person. You don't really think of so much of one being the cause of the other, do you? Although, I'll just say this. If all you had was height and didn't have much weight, you're going to have some serious problems. You really, I mean, if you're really tall, it's nice to have a little bit of an anchor. I'm always amazed, I don't know if you ever do this, but you can, if you look at rosters of like NBA teams, and you look at some of these guys that are just, they look like rails, they're just really tall, you'd be amazed at how heavy some of those guys are. You know, they're skinny and they weigh 220 because they're unbelievably tall. You do need some, well, like I said, you need a little bit of an anchor too. Anyway, I would say though, despite that, I don't think we would call one a response and one a explanatory there. How about C? Inches of rain in the growing season and the yield of corn in bushels per acre. I think we got a response there. And then bushels yield per acre would be the response. Just think about that situation for a minute. I agree with you. However, there's problems with that model. Because you know, I mean, I hate to even think about it, but you know what happens if we have a spring that's way too wet? Seems to me back about 5 to 10 years ago, we had one of those where it just was unbelievably wet, and they actually lost their crops. Too much water actually will be damaging too, right? But generally speaking, too dry, not much output. More water, better output. But if that goes to extremes, that gets messed up too, doesn't it? So anyway, I would agree though with your assessment. How about D? A student's scores on the SAT math exam and the SAT verbal. Two variables. Does one kind of cause the other? I don't think so either. Now, actually, it's probably some other lurking variable, like, I don't know, probably caring parents is part of it in there, and how healthy of a background you've had, all kinds of factors. How about that part E, a family's income and the years of education their eldest child completes? I think you'd find a fairly strong relationship between the two. I hate to say it, but lower income probably is going to translate in many cases to a what? A not so high level of education. Although supposedly today anybody who really, really wants it is supposed to be able to get it. But you know how that goes. Do the people who really need it even know how to apply sometimes? Possibly not. It's an age-old problem. I think it's a lot better though, isn't it? Seems now if somebody really, really wants to go to school, there probably is a way to do it. And they can probably go as far as they want. Okay, so good. That was a good practice. So not everything can be put in the explanatory response categories, but some things can. Okay. So what I haven't shown you is let's do a scatter plot on the computer. Okay? So you're going to find this to be nice and easy, I believe. Let's see, I got to get to the right course here. You know, it's been a chapter where we haven't done any of these data files, so we're kind of coming back here. Chapter 4, you'll see there's a bunch of data files again. And I'm going to take that bird colony thing so we can kind of eyeball and compare. That was exercise 4.4. I'll be showing you in Excel 2007, but I'm going to talk a little bit about 2003 too. Okay, we got our data in just two columns, percent returning, percent new. This is unusual. I'm going to tell you to highlight your data first. Usually we always waited with that. So I'm actually grabbing, and because you're doing bivariate data, you're actually going to grab two columns, two variables. Okay, I got it highlighted. Now in Excel 2003, you just click on the, what is it called, the chart wizard, which is this cute little color bar graph, somewhere up toward the center of the title bar. Okay. In 2007, it's slightly different. You have to do insert on the menu, and then you'll see a bunch of graph types pop up. You want the one called scatter. It's the second last one in the list. Okay? When you click on that, it'll give you a choice. You want the one that's not connected, the very first one. And basically, that's it. There's nothing else to do. You click it, you got your scatter plot. And I think you'll agree that it looks fairly, you know, with automated units and everything, it looks fairly similar to the one I made by hand. If you don't want that, the only bad news is that, you know what, I should really try this. Hang on, I'm going to try something I can't remember. I'm going to see if you include the titles, if they automatically get included. I can't remember. Well, at least the title comes up. So you might even want to grab, at least it's a little bit better. I was going to say, it would be great if we had these two axes labeled. We still don't, but now, at least we know the y-axis. This is new, this is returning. You might have to write that in. And if you don't want this little knob, that new over there on the side, you can just, I mean, they're all new, so you can just click on it and delete it. And then if you just label the two axes, you got it. And the other class, and by the way, then I would maybe just cozy it up a little closer, only for this reason. Somebody in the other class said, hey, when it comes to printing, how do you print these crazy spreadsheets? You probably noticed sometimes when you print things, you got half a graph on one page and half on the next. And one thing you can do is highlight, tell the computer how much you want to print. So like if I wanted to print this data in this graph, I can just click and drag just enough to surround what I need. And then when you do the print, the options come up. You'll see one of the options is print the selected, yeah, right here. Print what? Instead of active sheet, change it to selection. Now it'll just print that part that I highlighted. And in the old days, Excel was really bad this way. And somebody would want to print a spreadsheet, just a couple columns there, and they'd say print. And it would print reams and reams of spreadsheet cells. It didn't seem to know when to stop. And you know, these things have something like 64,000 rows. And poor guy who printed that would quick go grab the part he wanted and get out of there quickly, because then everybody else is standing there waiting for the printer, and and it's printing this wallpaper, and everybody's going, all right, who did that? You know, of course, by then you're gone because you ducked out real quickly. You don't have that problem anymore, but this is a good way to just print real compact. You can also do preview and find out if it fits on the sheet. Here, I'm going to do that. Not quite. You see how the right side of the border on my graph is? So I'm going to do one more thing. I'm going to say, we'll escape, and I'm going to, whoa, that isn't what I wanted to do. I'm going to grab this thing. I'm going to stick it under here. Now I'm just going to print this. So now let's try it again. Print, selection, preview. Yeah, fits on a page now. So that's another thing you can do to save a little trouble, do the preview thing. And then I got to tell you, I got some pretty strange looking graphs with some of those assignments. You know, I was like, well, I wonder what this is. And I found out it was part of a graph from a different place in the pile, and that was, yeah, it wasn't the person's fault. It's just something you got to watch out. Okay. All right. So once again, highlight data, insert, scatter, and pick the scatter that's not connected. Maybe just label your axes, and you're ready to go. I'm just going to tell you, this chapter is tied very closely to chapter 5. In chapter 5, we're actually going to learn how you can find a line that cuts right through the center of that data. It's actually pretty cool. That's a process in chapter 5 called regression. I'll wait with that because we're not there yet. But it'll actually not only plot the line, but tell you what the equation is. It's pretty neat. Okay, back to our... Yeah, and we'll just talk a little bit more these last... this 4.4, we'll talk a little bit about that. Okay. Every once in a while, there's a way to sneak, you know, as you guys know from chapters 1 through 3, what are the two kinds of variables we talked about in the beginning of the year? One of them was called numerical, the other one was called categorical. Well, everything we're doing now is all about numerical. There are some ways you can sneak categorical stuff onto these graphs. In this case, look at this scatter plot. You'll notice they use color here. If you read the caption, it says we have the mean SAT verbal score and the percent of high school graduates who take the test, which is interesting, by the way. I got to be careful, it's pretty interesting, but let me first point out, it says with the southern states highlighted. So in this case, they made the southern states this orangish red. Now, nothing outstanding shows up, but it could have happened like maybe all the reds would have been over here, and all the blues would have been over here or something, then that would have really told us something. But anyway, this is one way of sneaking categorical stuff onto a scatter plot. I'm going to show you another one. Oh, by the way, just a comment. This is kind of interesting. You see what this is saying? Look, on the x-axis, we have the percent of high school grads taking the SAT. And on this scale, we have the mean verbal score. So, you see what's happening here? As a higher percentage of students in the state take the test, it's not encouraging. The score goes down. As a smaller percentage of people in the state take the test, the scores go up. So I guess what that's saying is, the people that have to really urge to take the test probably aren't quite as good. Because when they throw everybody in there, it goes down. All right, here's the second one I wanted to show you. This is a scatter plot, and this is clever. Instead of putting dots, they use the two-letter state abbreviation, which I know is probably too small for you to see, but the point is they snuck some categorical data on there, and they still act like points. Okay, by the way, this one is the National Assessment of Education Progress. So this is like a test, kind of like an achievement test. As the scores go up, murders go down. Got that? As the scores are worse, we have a higher percentage of murders. You get better scores, so let's get those people educated. Huh? So I guess that at least makes some sense, huh? As you get a little bit smarter, you probably realize killing might not be a good way to go. I don't know. I hope. But anyway, I don't know. Where is Wisconsin? I don't see him on here. Does anybody? Did anybody find Wisconsin? Yeah, I don't see him. Mississippi, not in a good place. Louisiana, Minnesota, Montana, North Dakota, Midwest, like it at least. Okay. If you haven't already, get in there and start reading chapter 4. I'll see you on Wednesday.